So we're going to start all examples where we are graphing a function using transformations by first identifying what the parent function is. That is one of our 8 functions from our previous lesson. We see this exponent of 2 right there. This parent function is x squared. I'm going to start off with just a graph of what the original parent function looks like. The graph of x squared is U-shaped. Its graph is a parabola. I'll label 3 points that are on this graph, and we will track these points through their transformation. And I'm just choosing 3 random points. Generally speaking, if I can, I'll try to choose a point with a negative x-coordinate 0 and a point with a positive x-coordinate. I'm also going to make a table for this because, again, you could choose to go through these examples either using a table and then sketching the final graph, or by just doing a bunch of graphs. So there is our parent function. Let's start with our first transformation. There are 2 transformations happening inside of this function. One of them is this division by 2 that's happening with the x, and then another one is that minus 3. We have to figure out which one is first. We're following order of operations. If we had to plug in some x value, for example, say we're plugging in 6 to this function, what would affect the 6 first? The division by 2 or the minus 3? The division by 2. So that division by 2 is our first transformation. This x divided by 2 squared, which I hope we realize is the same thing as 1/2 times x squared. And I wrote it like that because to help us figure out what transformation it is, we're asking ourselves, how did we get from this equation to this equation? And what happened is that we replaced x with 1/2 x. And it's worth noting that the absolute value of 1/2 is less than 1. That, replacing x with 1/2 x, let's erase these circles here, we can see that that is a horizontal stretch, replacing x with ax where the absolute value of a is less than 1. And so for a horizontal stretch, we will be dividing our x-coordinates by a, dividing them by 2. So 1, I do know that this transformation is a horizontal stretch. I'm going to draw what the new graph looks like. If we are stretching out the function horizontally, then we should expect the graph to look a little bit wider. So I'll draw a graph that's a little bit wider. I'll label the points on it in a second. We get the new point during a horizontal stretch by dividing our x values by a. In this case, a is 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So the y coordinates are not going to change, right? This is happening horizontally, so it's only going to affect our x coordinates, and the x coordinates change by -2, 0, 4, because I just took all those x values and I multiplied them by 2. So labeling the points on the graph, this is now at -2, 1. This is still at 0, 0. And this is now at 4, 4. If you're doing graphs, do make sure that you're labeling your x and your y axes. The second and final transformation of this is whatever this -3 is doing on the outside of that x over 2 squared. To figure that out, we're looking at the difference between this equation and this equation. We're asking us, how did that equation change? And we can see that the equation changed by us subtracting 3 on the outside of the function. So now I go up to my table and I look for where did we subtract on the outside of the function. That happened in number 2, which tells us that our graph is going to go down 3. And to get our new points, we will be subtracting 3 from our y coordinates. So I now know that the second transformation is a shift down 3. I know what that new and final graph will look like because I'm going to take the graph from before that has already been, I'm not writing the equations here. That's okay. We have them here. I'm going to take the graph from before that's already been stretched horizontally, and now I'm going to move it down 3. And let's talk about how to get the new points. To move down 3, we need to subtract 3 from our y values. So I'll take 1 and subtract 3 to get -2. 0 minus 3 is -3, and 4 minus 3 is 1. The x-coordinates of -2, 0, and 4 did not change because the graph was just going down. So we now have the point -2, -2, 0, -3. Oh, I moved that down too much. And here's the point 4, 1. And let me reconnect these. And then this graph here is our final graph. That's our final answer because this function only had 2 transformations.